Hello, my name is Rob Reynolds. Welcome to Mat-073 Intermediate Algebra. Today we're going to be looking at using exponential notations in multiplication and division, and also how to multiply exponents being raised to powers. Lastly, we'll look at how to convert scientific notation. So quickly, some rules of exponents. Maybe you've seen this before. X squared times x cubed. You rewrite the base and add the exponents. The reason that you do that is because x squared is literally x times x, and x cubed is x times x times x, and then all together that's x to the fifth. When you divide, you're going to be subtracting, so be careful. X to the sixth over x squared is not x to the third. You don't take 6 divided by 2. You subtract 6 minus 2, and that's x to the fourth. This is called power raised to a power, so an example of that would be x squared cubed. So here, if you have two bases in example 1, notice that we added the exponent, but if there's only one base, we're going to multiply and get x to the sixth. This is the distributive property for exponents. You can distribute, if you have xy cubed, you can distribute that 3 to each term, so x cubed times y cubed, and that distributive property not only works for multiplication, it also works for division. Anything to the 0 power is 1. I think I can prove that to you really quick. 2 cubed means 2 times 2 times 2, or 8. 2 to the fourth is, let's go 2 squared is 4. 2 to the first is just 2. And so let's go patterns. This is a 2, this is a 2, this is a 2, 2, 3, 2, 1, 0, and half of 8 is 4, half of 4 is 2, half of 2 is 1. If I expand this, 2, 2, 2, 2, I'll get another 2, 3, 2, 1, 0, negative 1. Half of 4 is 2, half of 2 is 1. Half of 1 is 1/2. So there's our last, it's called the reciprocal. So if I have something like 2/3 to the negative first, then that would equal 3/2. So when you have a negative exponent that doesn't make a negative answer, I sometimes will see students try to tell me that this is equal to 1/2, and that's not true. So negative exponents do not cause negative answers. They cause the reciprocal. So let's look at some examples here. This would be rewrite the base and add the exponents. X to the 8th. Here the base is negative 4, so I'll just write the base and then add the exponents. Well, signs are different. I'm going to subtract and keep the sign of the larger. This negative here means reciprocate, so I'm going to find the reciprocal of negative 4, which is negative 1/4, and then I'm going to raise it to the 6th power, and then I'll distribute, and also distribute to the negative, but negative 1 to the 6th is going to be a positive number, positive 1, so I don't have to worry about the negative. 1 to the 6th is 1, and 4 to the 6th is a massive number, maybe somewhere around, well, I don't know, it's all relative. I don't know if 4,000 is massive or not. Moving on, I have 7 times negative 3, negative 21. Let's look at this. Rewrite the base, which is a, and add the exponents. 4 and negative 2 is 2. Rewrite the base b and add negative 3 plus 1. There's a 1 right here, is negative 2. And generally, we don't like to leave negative exponents. So I would recommend that you rewrite this as negative 121a squared, all divided by b squared. Again, rewrite the base and subtract the exponents for division. So the base here is 3. 4 minus a negative 5. Remember, you can have that double negative, and that really just means plus, so it's 3 to the 9th. Again, it's your discretion if you want to type that into the calculator or not. I'm just going to leave it 3 to the 9th. It's a big number. Rewrite the base, subtract. Negative 3 minus 5 is negative 8. And again, I would probably just leave it. I'm going to reciprocate, so this is negative. I'm not going to leave a negative exponent, so I'll rewrite it as 1 over 8 to the 8th power. 18/4 reduces. I can divide top and bottom by 2, so this becomes 9/2. So I'm going to have a 9 up top and a 2 down bottom. Let's deal with the x's. If I just look at the x's, I'll rewrite the base, which is x, and subtract 5 minus 3, which is 2. If I do that also with the y's, I'll rewrite the base, which is y, negative 3 minus a negative 6, which will give me y to the, well, this is really a positive in here, so this is really negative 3 plus 6. And I'll probably leave the answer like this, but I want you to recognize that this is the same thing as 9/2 x squared y cubed. Let's see how the author put it up front too. So you could leave it either way. You can leave all this in the numerator and leave a 2 in the denominator. That works as well. Power raised to a power, we're going to rewrite the base and multiply. 6 times 9 is 54. And over here, I'm going to do power raised to a power again. I'll multiply negative 20n, and then using the rule of leaving no negative exponents, I'll rewrite this as 1 over x to the 20n. The next rule says we can distribute this n to both terms. So we'll do a to the n and b to the n. An example of that would be this 4 gets distributed to all 3. Well, these aren't actually terms, but they're not separated by a distant subtraction, but it becomes 3 to the 4th. X to the power raised to a power is going to be 16, and y to the negative 20th, 5 times 4. Again, I'll probably try to simplify this. 3 to the 4th is 81. I'll leave x to the 16th, but the negative exponent says reciprocate, so I'll put the y in the denominator and change its sign from a negative to a positive. So again, if I see 1 over y to the negative 3rd, I'll just throw that in the numerator and make it y to the 3rd. So the rule is put it where it's not and change the sign. If you have y to the negative 3rd, I'll put it in the denominator where it was not, because it was in the numerator. It's like y over 1. And then change the sign of that exponent. So instead of a negative 3, I have a positive. So put it where it's not and change its sign. Continuing to the next example, I'm going to distribute the negative 3. I guess there's a couple ways you could do this. You could approach it also as 1 over negative 2x to the negative 3rd, y to the 5th, and then raise it to the positive 3rd, but I think it's easier to do it this blue method. Let's distribute this negative 3. So negative 2 to the negative 3, x to the negative times negative is positive, and y to the negative 15th. So I'm going to throw everything that's a negative into the denominator, so I'm going to leave x to the 9th in the numerator. Negative 2 becomes a positive 3, and the y to the 15th becomes positive. And so I think my final answer, well, this guy is a negative, so I have a negative fraction. I'll put that out front. Doesn't matter if it's in the numerator, denominator, or out front. I just need to make sure I have a negative. 2 cubed is 8, and then I'll keep the y to the 15th. So I think my final answer, yep, author agrees. The next rule says we can distribute again over division. So I'll rewrite this as w to the negative 12. That's 3 times power raised to a power. But I'll also take the negative 4 and distribute to the denominator. So I'll get a y to the 8th. Leaving no negative exponents, I'm going to throw this w where it's not into the denominator. So it's really 1 over w to the 12th, y to the 8th. the next one, I'm going to distribute this 5 to every term, numerator and denominator. 3 to the 5th, you could punch that in and get a number if you'd like. I think that's around 243. So I have an answer of 243 a to the 15th, that's the 5 times the 3, b to the negative 20 over 4 to the 5th. Wow, these are big numbers. Again, that's that 1024. I think we talked about that earlier. B to the, and then 2 times 5 is 10. It looks like I can take care of at least my b terms. I don't know if 243, if there's a common factor I would try to reduce. I don't think that's going to reduce. I'm trying to think of it doesn't divide by 2 or 3, 5s or 7s. So I think I'm going to leave the 243. I'm going to leave the a to the 15th. I'm going to leave the 1024. But the b's, I'm going to rewrite the base and then subtract. So it's negative 20 minus 10, which is negative 30. But then I'll throw that in the denominator. So it becomes b to the, let's see, did I do it right? Yeah, I think, yep, I think the author agrees. All right, so let's take a look a little bit at scientific notation before we end this video. Scientific notation, the important thing you need to remember about that is that if I have like 10 to the 5th, I can only have one leading number out front. So it's like 3.2 times 10 to the 5th. So times 10 to the 5th really is 1, 2, 3, 4, 5 zeros. So that would, if I put the decimal in the correct place, or the comma in the correct place, that's equivalent to 100,000. So what that means is really 3.2 times 100,000. So let's take a look at an example. Make sure that you have something between 0 and 1 for negative exponents, and for positive exponents you better make sure you have an answer between greater than or equal to 10. Let me show you what I mean here. So to convert mentally, I need to put 8.5, just one number in front of the decimal, times 10 to the something. So you need to decide if it's 1, 2, 3, 4, a positive 4 or a negative 4. And the rule that I like to use here is if this number gets smaller, which it is, 85,000 is a big number, and I've changed it to a smaller number, 8.5. So if the number gets smaller, then the exponent gets larger. And the exponent was a 0 because 10 to the 0 is equal to 1. So I was really just multiplying by 1. So the rule says if the number gets smaller, then this exponent gets larger. So I'm going to use a positive number here. Let's try this. This is going to be 8.97 times 10 to the something. Well, let's see. 1, 2, 3, 4. So again, it's a 4, but I have to decide if it's a positive 4 or a negative 4. So the rule states if this number gets, well, this time it's getting larger. It started as a small decimal. So if this number gets larger, then the exponent gets smaller. And so it looks like author agrees with that rule. So let's convert back. I'm going to give you something in scientific notation. I'm going to multiply by 10 to the 6th. This is easier because if it's positive, you just move to the right. So I'll go 1, 2, 3, 4, 5, 6. I'll add zeros. For any spaces, let's see, I need 3 zeros. Go back. Try to add some commas. 8,432,000. This means move to the left. So if it's negative, I'm going to move to the left. If it's positive, I'm moving to the right. So moving it to the left, I'll go 1, 2, 3, 4, 5, 6, 7. I'll put a decimal out there. So I have a lot of zeros, maybe 1, 2, 3, 4, 5, 6, because then I'll hit the 4, 2. So I moved a total of, it was here, 1, 2, 3, 4, 5, 6, 7. So final answer is a very small decimal number, but I've got 6 zeros in there. If you're going to multiply, we can just break this up and make this 3 times 4 times 2 times 1, and then 10 to the 8th and 10 to the negative 5th. So let's do this separately. So this is 7.14 times 10. I'm going to rewrite the base and add the exponent. Final answer. And last example, I can divide 6.2 divided by 8 is about 0.775. And then I'm going to go times 10 to the, well, I'm going to rewrite the base and subtract. So negative 9 minus 8 is negative 17. And you could, we can't leave this because remember, you can't write this in sign notation because my leading coefficient is not a number. So I need to move this decimal one more place to the right to make it 7.75 times 10 to the, well, I moved the decimal one place, so it was negative 17, so I need to either go to negative 18 or negative 16. And again, the rule states if this number is getting larger, then this gets smaller. So I need to get it smaller by one movement place. So one smaller than negative 17 is negative 18. That's why they wrote the negative 18 opposed to leaving it in negative 17. This is not scientific notation because you need a digit out front other than 0. I hope you found this video helpful. Email me with any questions. Thanks.